talk about radioactive decay and the primary types of decay. Radioactive decay is a process by which an unstable atomic nucleus loses energy by emitting particles or radiation. To understand this, let's go from an atom model. In an atomic nucleus, protons and neutrons are sloshing around against each other. Inside of the nucleus, there is a lot of complicated physics going on. First, we have the strong nuclear force, which forms quarks, the smallest particles, into neutrons and protons. Some of this force leaks out of the neutrons and protons, which forms the neutrons and protons into the nucleus. Since we all know that protons are positively charged, protons in the nucleus want to push each other away since they're all positive. Here, the strong nuclear force acts like a glue, gluing the protons together and holding them with neutrons. At this point, there is a force called weak nuclear force, which can transform a proton into a neutron and vice versa. Most atomic nuclei are stable most of the time. The repulsion force of protons balanced out with the strong nuclear force, which keeps nuclei together. But sometimes things can become unbalanced. If there are too many protons in a nucleus, the force they repel each other will become very strong and overwhelm the strong nuclear force that's trying to hold a nucleus together, making the nucleus unstable. If there are too many neutrons, the nucleus can also become unstable. Even though neutrons help to hold a nucleus together, but if there are too many of them, the strong nuclear force, which holds both neutrons and protons, can't always keep everything together and prevents neutrons from wandering away. When a nucleus isn't balanced, radioactive decay happens when the nucleus reshuffles and reorganizes itself to find a new, stable situation. The different ways a nucleus rearranges itself leads to different kinds of decay or radiation. Alpha decay. Alpha decay is a nuclear decay in which the parent nucleus emits alpha particles, which consist of 2 protons and 2 neutrons. It is identified as helium-4 nuclei. The number at the top represents the total of protons and neutrons in the particle, which is the mass of helium. The number at the bottom represents the number of protons. In this case, it tells that 2 protons are losing in the nucleus, and the 2 protons have a positive 2 charge. An example is the nucleus of uranium-238 undergoes alpha decay. In this example, the alpha particle helium is being ejected from uranium-238 to form thorium. Alpha decay or radiation can be blocked easily with nothing more than a sheet of paper. Beta decay. Another common decay process is beta decay. It's simply a high-energy electron that is emitted from the nucleus. You might think there is no electrons in a nucleus. That's right. In beta decay, a neutron turns into a proton by the weak nuclear force we mentioned previously. And at the same time, an electron is formed in the nucleus during the transformation and is ejected out of the nucleus. Beta particle is represented by this. The number at the top is 0 because it represents the mass of the total of protons and neutrons, and there are no protons or neutrons in an electron, so the number assigned it is 0. The number at the bottom is -1 because an electron has a charge of -1. Thorium-234 is a nucleus that undergoes beta decay, where thorium ejected beta particles and form protactinium. For beta decay, it requires a heftier, like a metal sheet, to block it. Gamma decay is a type of decay gets rid of its excess energy by releasing gamma rays, very high energy light waves or photons, similar to X-ray but stronger. Gamma decay happens after alpha and beta decay or some other nuclear process. A nucleus might be more stable after those processes, but still have extra energy, which makes the nucleus excited. Therefore, the nucleus releases gamma rays to get rid of these extra energy. Because gamma decay accompanies nuclear reaction of all types, so an example for it would be like this. Uranium-238 undergoes alpha decay, then emits 2 gamma rays in addition to the alpha particles. You need an entire block of lids to block gamma decay because of the high energy of gamma rays. An example of radioactive decay in real life is gamma and alpha radiation emitted by radionuclides present in building materials surrounding soil and the air. But no worries at all. These radioactive decay usually occur at a very low, naturally occurring level, and they are unlikely to harm your health. Now you know the radioactive decay and the primary types of it. There is still a lot about radio decay we didn't cover, but I hope you learned the basics and enjoyed this video. Thank you.